Have you ever wondered, how do I add or subtract rational expressions with different denominators? I'm sure this is a question you've had often in your life, and I'm going to try my best to explain it in this video. The steps they give us aren't always the steps that I follow. What they do is they do a process where they find the least common denominator. Because in order to add fractions, one option is to do the least common denominator, which will make and then make the denominators the same. And then when the denominators of fractions are the same, then you can just add or subtract the numerators and put that all over that common denominator. So for example, if I follow those steps on example 1, my denominators are 7a and 6a. So if I'm thinking about the least common multiple, of 7a and 6a. Well, the least common multiple of 7a and 6a, well, I need 7 for sure, and I need 6 for sure, but I only need 1a. So the most 7s I see is 1, the most 6s I see is 1, and in terms of looking at these as individual boxes here, or parts, then the most I see in any one of those boxes is 1a. So that means my LCM, which is the least common multiple of the two denominators, so that means it's going to be my LCD, is 42a. So now the goal is, how can I write 15 over 7a as something over 42a? Well, to do that, all I need to do is multiply by 6. So, of course, I would multiply the top by 6. And so 15 times 6 would give me 90. And then I'm going to do the same thing for 8 over 6a. I need that to be 42 over a. So, in order to do that, I need to multiply by 7. Well, I must do that to the numerator as well. And so 8 times 7 is 56. So these are the two fractions I'm able to add now. So now I can say 90 over 42a plus 56 over 42a equals, well, if I add that on the numerator, I get 146 over 42a. So I add the numerators and keep the denominator when it's like. And then, of course, I want to think about reducing. And so here, I can definitely cut the top in half. So if I take and divide 146 by 2, I'm going to get 73 over, and when I divide 42 by 2, I get 21. So that would be my final answer. Now, I kind of wrote all over the place, so let me clean this up a little bit to show you what I did. So our original problem was 15 over 7a plus 8 over 6a. I found that the least common denominator was 7 times 6 times a, which was 42a. And in order to make that 42a in this first fraction, I needed to multiply the denominator by 6, which meant I also had to multiply the numerator by 6. For the second fraction, I had to multiply the denominator by 7, so I also had to multiply the numerator by 7. I also want you to know this. Now both denominators have a 7, both denominators have an a, and both denominators have a 6. Right? So they're identical now. They have the same things, and I don't have too much of any one thing. They're just perfect. And so now when I multiply, we got 90 over 42a plus 56 over 42a. And so now I'm allowed to add my numerators and place it over my common denominator. So that's how I got 146 over 42a. But I still need to think about reducing. And so I noticed those were two even numbers, right? 146 and 42 are even numbers. And so when I divided these, I got 73 when I divided each of these even numbers by 2, I got 73 on the top, and then 21, which will be with the A on the bottom. And that's all I can do for dividing. 73 is probably prime. All right, there's another option that you can do. This option does not work very well for most problems, especially if you have adding and subtracting in your denominator. But there is another technique that some students may be familiar with when you add fractions called cross and smile, meaning that if I had 15 over 7a plus 8 over 6a, cross and smile is when you multiply the first numerator and second denominator, then you multiply the second numerator and first denominator, and then you're going to multiply the two denominators together. Right, so 7 times 6 is 42, a times a is a squared. And then you're just going to simply add the numerators together and put it over that product in the denominator. So, cross and smile, you go across this way, that'll be your first number. Then you go across this way, that'll be your second number. Of course, the operation here was to add them. And then you multiply both your denominators together to get your new denominator. And so now that's sufficiently highlighted too much. But what you're going to see here is that my answer comes out almost like the other one, but it's 146a over 42a squared. So not only would I simplify the 146 over 42, but we know, so I'm still going to have the 73 over 21, but a squared would leave me with 1a on the bottom. So that is a really awesome fast technique for this particular example, but cross and smile doesn't always work out very well. So you want to be careful with cross and smile. Finding the LCD is always a good option because it always works. Example 2 is another one in which it's not the best option to cross and smile. It just depends. What's wrong with example 2, though, is it's where these two denominators are almost the same except for its subtraction that's been turned around. And so if you remember, we talked about the fact that if I turn around subtraction, so if I turn around this subtraction, I have to multiply by a -1. Well, what's going to happen in this case is it's going to change this negative to addition. So what happened here, guys, is that for that second part, if you turn around subtraction, 2x minus 6, you have to take out a -1. And so, and then I had this part over here. Well, these two negatives, subtracting a negative, because that would be a negative fraction, is addition. And so, let's see if I can write that any better. But this on the bottom, that's -1 times 2x minus 6. Again, factoring out a -1. So now I just have to add, and 5 plus 3 is 8. Anything I can factor? Well, I can factor a 2 out from the denominator. And then 8 divided by 2 is 4, so I'm left with 4 over x minus 3. So that's getting the least common denominator. And here it wasn't so bad, or adding getting the least common denominator. It wasn't so bad because those denominators were so close. I've seen this before, right? We've seen this several times where the subtraction has been reversed. And you can reverse subtraction as long as you factor out a -1. That means just as long as you multiply by a -1, you can do that. If you want to see how this would look with the cross and smile, this one wouldn't be too bad. So here, what I would do is I would multiply these two together. So that would be 5 times, so this is going to be a distributive property. That's the only thing that makes this a little bit harder, but you should know the distributive property. Minus, right, because there's my minus sign right there, just bringing that down. Then let's do these two multiplied together. So 3 times 2x minus 6 all over, but now I have to multiply these together. 2x minus 6 times 6 minus 2x. And that's where this becomes, you know, a little strange. So I took these two and multiplied them together. So I don't know if, you know, if I should have even bothered to try this with the cross and smile, but it is an option. It's just sometimes it makes things worse. So in the numerator, I would have, if I distributed, I would have 30 minus 10x minus 6x plus 18. All over some mess down here, right? So I don't know if I even want to factor that yet. So in the numerator, I would have 48 minus 16x. And you can actually factor out a 16, which would leave you with 3 minus x. So I went ahead and took care of that numerator because in the denominator, you can see that you can remove a 2 from that first one. And then you could also remove a 2 from that second one. So let me make that a little bit bigger. So I have 48 minus 16x over that denominator, right? And then I simplified this into 16 times 3 minus x. So what I'm saying in the denominator is I could take this first piece here and I can factor out a 2. So that would be 2 times x minus 3. And then I could do the same thing with the second piece, the second denominator here. But here, if I factor out a 2, I would be left with 3 minus x. So what have I got going on here? What can I cancel out? Well, now I can definitely see that I can cancel out this and this. And then notice that I've got a 4 down here, right? Isn't that 2 times 2 is 4? And so 4 goes into 16. And I can cancel those out. It goes in 4 times. And so lo and behold, I am left with 4 over x minus 3, which is the answer I got doing it the other way. All right, let's do some more. When you're subtracting or adding fractions and whole numbers together, it's a lot easier because if you remember, this whole number of 3 has a denominator of 1. And so in order to make these fractions have the same denominator, this whole number needs a denominator of 2x minus 3, right? So now the denominators are the same because that number 1 is just, I could put a 1 over here, it won't change anything. So I end up with 7 minus 3 times 2x minus 3 all over 2x minus 3. So that would be 7 minus 6x plus 9 all over 2x minus 3. And so adding that together, that would be 16 minus 6x over 2x minus 3. Move this down here. Actually, I need more space. Always need more space. Let me move some stuff really quick. Okay, so what did I do? The first step was I made each denominator the same, and then I simplified in the numerator, and then I ended up with 16 minus 6x over 2x minus 3. And so I notice in the numerator, 16 and 6 can be divided by 2, right? But that's all I could do. I mean, if I take out a 2, that would be 8 minus 3x over 2x minus 3. So why even bother? Nothing factors or cancels, so I would just leave it as 16 minus 6x over 2x minus 3. Okay, so example 4. Here I'm going to factor each denominator. You definitely, I mean, you could cross here and small, but man, it'd be bad. And that's why I think it's best probably to just do the old-fashioned, let's get a common denominator. So each denominator is one that factors using a simple diamond, right? I'm looking for, in this first one, what multiplies to -6 and adds up to -1. And if I think long and hard, these two numbers multiply to -6 and add up to -1. And then I'm looking for two numbers that multiply to 6 and add up to 5. So that would be x plus 2 and x plus 3. The way that I used to teach this concept was I used to teach it as looking at the denominators and asking who needs what. So the first thing I notice is they both have this, so they don't need x plus 2's. But this has an x minus 3, and this one needs an x minus 3. So I'm going to put an x minus 3 over here. And whatever I do to the denominator, I have to do to the numerator. So it's also going to get an x minus 3 up here. And then I notice, hey, this has an x plus 3, and this one needs an x plus 3. And so now my denominators all have the same thing, right? They each have a yellow, green, and blue. They each have an x plus 2, they each have an x plus 3, and they each have an x minus 3. So what we get, oh, that was almost good. In the numerator, I get 4 times x plus 3 plus x times x minus 3. All over, and there's no need to multiply this back out. It doesn't matter what the order is of these, but just leave them alone. All I need to do is simplify in the numerator. And by the way, guys, this process I did here, figuring out what denominator needs what, that was finding the least common denominator. It's just easier, I think, to do it that way. Just break down the denominators and see who needs what. What do they have in common? That's great. But then what does each of them need so that they match exactly? All right, so now in the numerator, I have 4x plus 12 plus x squared minus 3x. All over x minus 3, x plus 2, x plus 3. All right, so just did the distributive property. And now I'm going to combine like terms. So I've distributed, I'm going to combine like terms, so I get x squared plus x plus 12, oh man, all over x minus 3, x plus 2, x plus 3. I can't factor the top. If the top had been x squared minus or plus x minus 12, that would have factored into x plus 4 times x minus 3, and I could have canceled, and I would have been left with just that. But that's not what we had. So ignore what I just said. But that's as far as I can go, because that numerator does not factor. Let's see. Oh, I have a bunch of extra examples here that I was going to work. I will probably do most of them on paper, but I do want to explain to you guys, some of these are easy with cross and smile. Like, if I have a single denominator, that would be 7x plus 72 over 63. And that would be it, because 7 and 72 have nothing in common. Here's another easy one to cross and smile. That would be 11x minus 15 all over 55. So 11x minus 15 all over 55. C and D, you could also do cross and smile. But D, I think I'm going to jump to D. I think D is easier to just recognize. If you put an extra Z here, then that would be Z squared, right? So you'd have 6Z squared over 4Z minus Z squared. You can't cancel anything, so you're done. So if you can understand the process of least common denominators, then that's going to make your life a lot easier in a lot of instances. You know, this one right here, since 5 goes into 40, 40x would be your LCD. So you would multiply this by 8 and this by x. So they both would be 40x. But I'm going to do these and email them in a separate handout. So that's going to be this lesson.